So this is 3.6C, bottom of page 324, College Algebra, looking at example 4 when we're dealing with rational inequalities. So we need to make some adjustments before we get going. First of all, let's move all of this stuff over. So we have x minus 3 over x plus 4, and we're going to subtract x plus 2 over x minus 5 and say that that's greater than or equal to 0. Alright, so what are we looking for here? Once we do this, and we set it with an inequality to 0, we're looking for x values so that my y is greater than or equal to 0. I'm looking for an answer so that my y is above the x-axis. So what I'm looking for is what intervals is my graph above the x-axis. So that's pretty much what I'm doing. So now I'm going to just change this little guy right here, this inequality sign, and let's just do it in red here. We're going to make it an equal sign. And now I'm going to have to solve this. Well, the first thing you want to do as far as solving this is you want to get rid of these doggone fractions. So we're just going to do basic algebra and get rid of the fractions. Alright, and so if you remember, the way I do this is because I have an equal sign, I can multiply the entire thing by the common denominator, x plus 4 and x minus 5. Okay, I'm multiplying everything by that denominator. So when I do that, I get x plus 4, and I know this might be a little bit long, x minus 3, x minus plus 4 minus x plus 4, x minus 5, x plus 2 over x minus 5, and then I multiply x plus 4 times x minus 5 times what's on this side, which is a 0, so it automatically is going to give me a 0 there, so I don't do anything. So now I can start canceling. Cancel that and that, cancel that and that, and I'm left with x minus 5 times x minus 3 minus x plus 4 times x plus 2 equals 0. So once I do that, I'm just going to do the FOIL here and do the FOIL here. And when I do the FOIL method, which I'm not going to show you, you already know how to do that, I get x squared minus 8x plus 15. And that's in parentheses minus, and I'm just putting them in parentheses because of that minus sign. X squared plus 6x plus 8 equals 0. And I take that minus sign off, and when I take that, or the parenthesis off, and when I do that, it changes all of my signs to their opposites. Don't forget to do that. Okay, and then I combine all my terms, and I'm sorry, I can also take this parenthesis off here as well. Combine all my like terms, my x squareds go away. I end up with negative 14x plus 7 equals 0. And my x then is a positive 1/2. So that positive 1/2, that is telling me where this graph is going to cross the x-axis. Okay? So that's all I did. I went clear from up here at the beginning, and I solved for x, and I found the 0. The 0 is where it crosses the x-axis. Okay, there's another thing I want to bring up as far as this original problem right here. And so what I want to do is I want to write this like I did earlier. Let's see here if I can move this down a little bit. Okay. I'm going to rewrite it again as x minus 3 over x plus 4. And remember, we put equal sign here. And that's how we started solving it for x. And then we moved everything around and was able to solve for x. Okay, before we get started with how to graph this, we found the root, or the zero, of the equation. It crosses at 1/2, but we don't know a lot else about it. Now, the other ones we did, examples 1, 2, and 3, we had just the polynomials that we graphed. Well, notice these fractions here. These are the ones that we have been doing, the rational expressions. These are called rational inequalities because there's an inequality sign here. But remember, when we were doing these, we've got these doggone denominators. And we have something that's very true here about our domain. Now, -4 and +5 do not work. And if you remember from the last lesson, those were our asymptotes. So, when we have our asymptotes, we have what are called, these asymptotes, when we're doing this, are called critical values. They're important values when we're looking at graphing this, because we're not only looking to graph this now in this lesson, we're looking to find out when our y value is greater than the x-axis or below the x-axis. And in this particular one, we are interested in finding out when our y value is above the x-axis. And that's where the critical value comes in, because the graph of this rational inequality is going to be different than just the graphs that we did in the previous examples. In the previous examples, we had graphs that looked like this, you know. But if you remember right, the graphs with rational expressions may look like this, this, and this. And in between there, we had asymptotes. Okay? And that's what we're looking at when we're looking at these rational inequalities like this. It's going to be broken graphs like that have some kind of an asymptote. So what are the asymptotes? The asymptotes are our critical values. So before we do these rational inequalities, we're first of all going to look and see what our critical values are. So our one critical value was at 5, and I just have a black dotted line there. Our other critical value was at -4. Okay, so those are important because those critical values break our graph into 3 intervals right there, right? But what else did we find out? We found out down here that my x was equal to 0. That is another part of this problem that's critical, because what happens is that becomes part of our answer. So let's get rid of, if we can, this graph right here. So we have a critical value of -4, we have a critical value of 5, and we also have a 0, which is 1/2 between there. Okay? So all 3 of those points are very important here, and actually those 3 points divide our graph up into 3 or 4 areas here. We have -4, we have +1/2 where it crosses, and then we have 5, which is going to be another one of the asymptotes. So asymptote, asymptote, and then the 1/2 is where the graph actually crosses. So we have this interval, we have this interval here to see what's going on, because actually, see, this graph could go up here to 1/2, above, 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 and then back down here. So this is another interval, because this is a crossing point where it goes from below to above. And this one here could also be a crossing point. Okay, so we just have to make sure that when we're doing rational inequalities with numbers in the denominator, we not only look at what x is equal to, but we look at what x cannot be. Okay, so that gives me my -∞, -4 interval. my 4 to 1/2 interval, my 1/2 to 5 interval, and my 5 to infinity interval. Okay, so we've done these long enough that you should be able to real quickly be able to pick numbers and find out where they're positive and where they're negative. So in this one we get a positive answer, so we know our graph is above the x-axis in that particular interval. There it goes below. 1/2 to 5, it's going to be above, because obviously if 1/2 is the 0 or the x-intercept, the graph crosses, so it's going to have to cross from either negative to positive or positive to negative, and in this case it crossed from negative to positive. Okay, and then the final one, from 5 to infinity. 5 to infinity, we are at negative. So we've got that. The question was just solve it. It didn't want a graph, but I'm going to put the graph on here anyway just to show you what it looks like. This is going to be that part of it. This is going to go up and then above. And then this one here is going to look like this. Very similar to this one over here, but down here. So that's what it looks like. So we do have one interval. We've got 2, 3, and then we have our 4th interval there. Okay, so should make it real easy to give me the answer, because the solution set is going to be where my answer is positive. Okay, where it's greater than 0. Okay, and that would be here and here. And all you're going to do is put a u between those. So negative infinity to 4, and then 1/2 to 5, and and put a u there. And one of the things I want you to remember is when this problem was given earlier, this sign, let's see if I can find it. This sign right here was a greater than or equal to sign. So it was a greater than or equal to sign, which means that this is inclusive and this is inclusive because of the equal part there of my greater than or equal to sign. So don't forget that. Oh, wait a minute, I've got another mistake here that I need to take care of. This is a -4, and I only put a regular 4 on there. And actually, the 4 is not inclusive. Do you know why the 4 isn't inclusive? Now that I look at it and think about it, the 4 is not inclusive because at -4, that's our asymptote. Whereas the 1/2 is inclusive because it is just where it crosses the x-axis. 1/2 is part of the graph. Where here, the -4, it goes up to -4, but not quite to -4 because -4 is an asymptote, so it cannot include the asymptote. Same with the 5 here. It's a curve because it cannot include 5 because 5 is an asymptote. So don't make the mistake I just did. If you have an asymptote, it does not include it. But if it's a 0, it does. So the critical factors or the critical values do not include there in your answer. So that is it for 3.6 A, B, and C.